Okay, now we're going to look at a way to find the zero of a linear function, and there's a couple different ways you can do this. The first way is through graphing. So this video is going to concentrate on that, on graphing. So in order to graph these, because they're not written in standard form, we are going to use the good old method of using a table for everything. Okay, so let's set up a table here. Got x. We're going to call this f of x, and just writing that equals y. That's going to be our y once we figure that out. So what we're going to do is we're going to just pick some values for x and put them in. So I always start with 0. I like 0 because it usually gets rid of the x term. Well, it doesn't usually. It always gets rid of the x term. And then it gives you a nice easy answer to get at. So 3 times 0 cancels that out, and then you get 3. So we got 1 point there. All right, let's try another point. So if I use 2, and I go 3 times 2 plus 3, that's going to give me 6 plus 3, which is 9. It's a little big for my graph. So let's try 1. All right, so 3 times 1 plus 3. And you'll get better at this the more you do it. And that gives you 6. That will just fit on my graph. And then let's pick a negative number. Let's do negative 2. So 3 times negative 2 plus 3. That gives you negative 6 plus 3, which is negative 3. So I've got, I can't really use this one right here, but I can use all 3 of these. All right, so I got the point 0, 3 from this first one. So that would put me about right there. Next one is the point 1, 6. It's going to put me right up there. And then negative 2, negative 3 puts me down in the third quadrant here. And then I'm going to draw a line that goes through these. That's going to hopefully straighten out and not be quite that crooked. And then if I look at this, okay, I'll put my arrows on my line. If I look at this, all I do is just identify where does this go through the x-axis. First of all, does it go through the x-axis? And then once I identify that it has gone through the x-axis, where is it going through the x-axis? And it's going through the x-axis right at about negative 1. Okay? So my 0 of my function is x equals negative 1 for this one. So this would be my 0 of the function. And that's the solution to it, right? Or the root of the function, the 0 of the function. All right, let's look at another one. So this one's kind of weird because no matter what I put in for x, so like if I put 0 in for x, I get 6 because there's really nowhere to put x in. If I put 2 in, I get 6. If I put like negative 4 in, I get 6. So no matter what I put in, my f of x or y value is always going to come back as 6. So what you get from that is if you plot those points, and hopefully you don't even have to plot these points to see this, but what you get is you get this big line, right, that just kind of goes through the y-axis at negative 6. And we'll just take that and draw a line. Try to straighten it out a little bit. It is parallel to the x-axis. And because it is parallel with the x-axis, all right, so I'm going to say parallel to x-axis. That 11 is the sign for parallel, all right? Parallel. So it's parallel to the x-axis. And because it's parallel to the x-axis, that means it never crosses it, because that's the definition of parallel. Right? And if it never crosses it, that means that there's no root to this, right? There is no 0, all right? No 0 to this function. Okay? Yeah, you have a y-intercept, but that's not what a 0 of the function is. 0 is, can I do anything to this to make y equal to 0? And there's no value you can put in that will have you do that. So this one has no root, or no 0 to it. Let's look at one last example here. So we're going to do our same thing with our x, and I'm just going to write y here because hopefully you got the idea that f of x and y are kind of interchangeable. All right, so if I put 0 in, I get negative 0, which is just 0, minus 5. That goes away. So that gives me negative 5. Now, if I put in another positive number, like say I put in 3, that's going to give me negative 3 minus 5, which is going to give me negative 8. So as you can see, as the x numbers get bigger, like they get larger positive numbers, you're going to get a smaller and smaller number. That's not going to fit on the graph. So I think our best bet with this is, for our second point, let's pick like a negative number. So let's pick negative 2. So you have negative, and then inside you got to put your negative 2 like that. That's where these get a little tricky. So negative negative turns this into a positive, right? So positive 2 plus negative 5 is negative 3. So you can see that the numbers start to move up a little bit. So I have 2 points I can use. I can use this 0, negative 5 point. That's going to put me right here. And then I can use this negative 2, negative 3 point, which puts me right here. So now what I'm going to do is I'm going to draw a line that goes through these. I'm not that line. Not that line. Let's try this again. Mr. Simons is having technical difficulties right now. Sorry, guys. My device is being really glitchy right now, but there we go. All right, so that's about right. Okay, I put my arrows on it, and then looking at that, just follow the line up where it crosses the x-axis, which is this right here. It crosses right about here. So my guess is that if I straighten that line out a little bit, that my 0 would be at x equals negative 5. All right? And then we'll talk about how to algebraically figure that out in a little while. Okay, so that would be the 0 of my function. Okay? So that's how you do these problems. So good luck with these, with trying these, and the next video is going to be on how do we do this algebraically.